We are going to discuss about the basic data structures. Uh, First, coming to the array. Basically, arrays are stored the elements in contiguous locations. That means if you have a storage box like this, and whenever we, let's say in C++, whenever we allocated the size of 50 of integers, so every int, for every int, let's take some space of one block. So 50 ints, so it will take the 50 whole blocks like this. This is 50th block. So if new number came to here, it will just store the 51 here. So if new element comes and 52 here, like that. So in this way, in our memory, the array store the elements. Coming to second, vector. Coming to vector, vectors are vectors inherent, like inside it built by arrays only, but small difference in the logic. What it is like, the arrays have a issue of when we are allocating the size of 50, if new element comes to when we are allocating the size of 50, let's say we allocated 50 size. In the meanwhile, remaining data structures occupied this space. Some other data structure occupied this space. So if 50 first element came to here, then there is no space here. So what it will do, it erases all these elements here and take the new space where it can accommodate 51 elements. So it free up this space, and 51 elements के लिए it take new space where 51 elements can accommodate. So this is the 51 element space. So it always expecting the continuous location. So for that internally array takes somewhat much time during this type of scenarios. So vector, what it is doing is like, whenever we initialize the vec of size like 4, whenever we initialize. So let's take again int as one block and size 4, so 4 blocks. Instead of taking 4 blocks, vector allocates 8 blocks here. 8 blocks. So if fifth element came to here, it just store the fifth element here. Sixth element came here, sixth. So up to 8th, there will be no issue. If ninth element came here, then only what it will do, it will again search for the empty continuous location where 18 elements can be stored. Even though ninth element came here, it will wait for the 18 elements location. So if still here 18 elements location available, so then it will occupy all the spaces up to 18 space, but the ninth element stored here. If in some situations, let's say here it is occupied in the previous case like that, let's say the ninth location occupied by some other data structure, then it deallocate this space, free up this space, and allocate the 18 space, allocate the space where 18 elements can accommodate, and it copy the 8 elements and store the 9th element here. So up to 18th element there will be no issue. So in the vector, the thing is like, we won't face the issue at every element, we will face after the double of the element. So let's say if in a college 500 students are there, if 501 student came, we may face the issue in vector, but 500 to up to 599 we won't face the issue in the allocation. But comes to array, we may face the 500 first element, we may face the 500 second also, because it might be a chance after 500 first element there some other data feature can accommodate the continuous space just beside the array. So in this way, vectors are better than the array, even though it's inner implementation of arrays. This is the logic they will do. And coming to next, that is called let's say linked list. What it will do is like, if there are if, let's say if this is the memory location. Wait a minute. So we have a linked list. Let's say this is the memory space. Let's say first element is stored somewhere. Now the space around that is occupied, but somewhere in this point one more space is there. For the second element, when came to the linked list, it will store here. So and the next element, there is no space here, so it just randomly check for the where empty space is there. Let's say here the empty space is there, it stores the element here. So these addresses are not continuous. Let's say if it address x, it can be x plus 500. It can't be x plus 1 every time. It can be x plus 200. So at random locations, wherever the location is available, they just store the new elements. Let's say first number came as 1, it stores the 1 here, and second number came here, it will store the second, and third number came, it stored the 3 here. So but the issue is like, during let's say for time being we call it as a ROM. Okay, during our program is running, we have to remember some locations, that is called RAM. Okay, so for time being I call it as a RAM. So in RAM we have to store every addresses. At x location there is one number, x plus 500 one number, x plus 200 one number. That whole thing has to be stored. So to mitigate that thing, in RAM they are storing only the first numerical location x. Other than that they won't store anything. But in this x location, including the number, they also store the next numerical location x plus 500. Here also it stores the next numerical location x plus 200. Like that, whenever in our RAM we only have the first number location, so we'll go for the here and we'll print that number. We want the next number. For that we just ask in that location only we store one more thing, that is called next numerical location. We will just go there and print that element, and here including that number there is one more value we will show, that is location of next number. We will go to the x plus 200 location. So in this way, in RAM we are only storing the first numerical location, but still we can print everything. So there is no need of space has to be available. There is no need of deallocate the space. Those things no need here. So linked list is good in this thing. And a similar way of explaining in our area also, the thing is like in RAM we will only store the first numerical location. So if you want next number, we will just print add one more. Just we will go for the next continuous element. So here also in RAM we will store only first numerical location. Here also we will store first numerical location, but we can traverse every number easily here, because just side to that elemental location, so it's easy here. But here further thing, we are storing one more thing, including the number, we are storing the address of the next number. That's the negative point here. Even though no need of continuous allocation, no need of deallocation, we have to store the number and next number address. Okay, so in ROM we may occupy more space, but still we can manage the whole space easily. So that's the good thing about linked list. So on top of the linked list, there are some data structures has built. First thing we will discuss is stack. So coming to stack, coming to stack, basically whenever the first number is stored in the let's say we call it as a ROM, right? So first number is stored here. So here the first number is stored, the location is x and the number is n. Okay, n1. So when the second number is stored, including n1, it will also store the okay, in our RAM we will only store the first numerical location. When second number came here, randomly we will check same as linked list. Actually it is built on top of the linked list. So randomly it will check the empty position. If somewhere it found, let's say at some x plus 250 at that location there is empty space, it stored the n2, and in n2 it stored the, including n2 it is also stored the x. So now here in our RAM we will only store the x plus 150, not x. If new number came n3 at location x plus 790, okay, in n3 we will store the in this location we will store n3 and also previous numerical location x plus 250. So here we will update our RAM with the latest number x plus 790. So if someone want to print all the numbers, we have only address of the last number, which is x plus 790. So we'll go there and we'll print the number n3, and we'll have previous numerical location, we will go there and we'll print the number n2, and we'll have previous numerical location next and we'll print the number n1. So we can only print n3, n2, n1. So to get n1 we have to go from n3 to n1. So actually stack we called as last in first out, right? Why? Because n1 is stored earlier, on top of that n2 is stored, and n3. So last which is get into stack can able to get out first, because we have the only store in stack, internally they are storing only the first memory address. So that's why it is last in first out. If you observe the stack member functions methods also, st.push, it only push the number at last, not at the first. Okay na? st.top, it only print the topmost element. There is no method called to print the middle element, because to print the middle element it takes much time, because we have to go here and go traverse back here. So we have this method. And st.pop, we can pop out the last number, and in RAM we can update the address of the updated last number. Let's say x plus 250 is the updated last number if you pop out n3. So these methods only we updated, no more new methods, because the internal implementation was done like this. So they can't do any other methods like st.first number. They can do that, but it taking much time, so they didn't made this method. So quite oppositely, in Q they just in Q we called it as last in stack last in first out, right? In Q first in first out. And when the first number came here, let's say we call it as a ROM, right? First number came here, x. In our RAM we'll store the number x, okay? And the new number came here at the location x plus let's say 590, okay? So in the initially in the n2 we stored the previous value x, but in the situation of Q we'll store the next number here, x plus 590. We won't update our RAM during the pushing, okay? So if new number n3 came, let's say x plus 750, just that previous number we will store the address of this number x plus 750. So whenever we want to print the number, we have only the first numerical location, so n1 we will print first, and at first number we have one more location for x plus 590, we will go there and print the n2 and n3. So here the which is where first is getting inside, that thing only we can access first. If you want to access n3, it takes much time, because we have to traverse whole numbers. That's why it is called first in first out. Here also if you observe the Q, we will have q dot push, because we can only push at one location, not push back, push front like that. And q dot pop to pop the first element here, and q dot front here, not top, front, because the frontmost element, okay? These are the methods you can say here. And one more thing is dq. Dq is so dq is the just combination of stack and q, because let's say in this diagram only I can explain. In n1 we are storing x plus 590, right? In our RAM we are storing x. If new number came, x plus 750, n2 at x plus 590, we are storing the x plus 750 for the next number. Wait a minute, I will say once more. If first number came here and second number came here and third number came here, in our RAM only we have the first number location. In DQ we have the first number location and last number location. Okay, and at every position we will store the previous number location and next number location. At n3 we will store the previous number location x plus 590, and next number location there is no location, so we will just store it as a null value. In our n2 we will have both previous value and next value, so x plus 750 is the next value and x plus 590 is the previous value. We will store both values. So in our RAM we have to store two locations, which is the firstmost number and lastmost number. If someone want to print from the first, they will use this thing and go here, print n1, and they will ask for your next number, because it has the next number location, it go here, and it has next number location, it go there. If someone want to print from the reverse order, they go for the second thing which we stored in our RAM and go here. It has the previous number location also, so it will go there, and it also previous number location, it will go there. So in the case of DQ, we can print from the both sides, but DQ has issue of, in ROM we have to store value, previous address and next address. In Q and stock only one direction ka address. So it is called DQ. It built on the doubly linked list, just linked list ka internal core idea. And now coming to stack. So in DQ, the methods, let's say DQ, we have push back method has there, because we can push from the back side, and also DQ push front. We can push from the front side also, and DQ dot push pop front, pop back. These methods can be there because it has the access of both direction. In RAM we have to store the two locations. In our ROM we will store the unnecessary thing, because to traverse fastly those things has to be needed. And coming to set. So DQ on top of the list linked list only set is built. Now for what problem set has introduced? Let's say we have vector, array, let's say vector and DQ. These are the most generalized topics because vector is much better than array. It solves every problems of array and it solves the new problems also. And coming to DQ, it solves the problem of stack, solves the problem of queue, and it solves the new problems also. So vector and DQ, abhi tak these two dashes are good enough. It is continuous location, it is at random locations, but storing addresses for everything. In our RAM we will only store the first and last address. Here in our RAM we will only store the first address. Okay, so if we want to find a number 7 in a set of values, vector, how it stored? It stored the values 1, 6, 9, 7, 5, 2. Let's say this is the vector storage. So if you want to find whether 7 is there or not, in these scenarios, what our vector can do? Vector has only the address of first number. So it will go here, are you 7? No. So it will go for the next continuous location. It will check. In this way, it will go for every number and it will determine whether 7 is there or not. Okay. So it will take almost much time. Coming to DQ, it is also will take much time. But if we modify somewhat DQ, it works very well. Let's say our first number is 9. We will store a random location 9. Here previous number, next number won't be there. Here at address axis we store the 9 like the linked list. Okay, if new number came, let's say 8. If 8 came, and it will check for the next empty location. Let's say here it is the empty location, it will store here 8. Before storing here, it also stores Okay, 9, it stores 8 here. So at at xth location it also stores, let's say 8 is stored at x plus 290 ka location, so it stores x plus 290. Okay, if 10 came, so in our RAM only we have the location of 9 only. If 10 came, it will check 10 is greater than or smaller than. 10 is definitely greater than this, so it will ask some random location and store 10 here, and it has some location like x plus 220, so it stores x plus 220. Okay, so what what it actually means is, in our location, in our xth location, we are storing the number, we are storing the location of my smaller numbers, we are storing the location of my bigger numbers. If new number came 11, so when came here my bigger numbers at x plus 220 का location, it go there, it ask आपका bigger numbers कहाँ पे है, so it is also stores two locations. Let's say the location is x plus 990, which is here, x plus 990, it stored the number 11. And if a number which is greater than 9, it goes here, and less than 10, which is 9.5, so it stores somewhere at 9.5 here, and location, let's say x plus 223, it stores x plus 223. In our RAM we only have the location of the first number, not of every location. So in a scenario like whether the number 11 is present or not, if anyone want to know, then you need to check every they just go for the xth location, and at x plus 240, at x plus 290 we have smaller numbers, x plus 220 we have bigger numbers, so we'll just go for the x plus 220 location. Here we have number 10, so we want 11 is definitely bigger than this, so we no need to go for the lower location, we have to go for the x plus 990 here. So in the no need, we are not wasting on 9.5 and 8, we are just directly go to the 11. So in this way set will help. So if you see the member functions also, set have insert ka member function, because you are just inserting the numbers. Okay, and set dot find, because it can find at lesser time, that's why find we can give the number 11. Okay, and st dot arrays, we can erase the number 11 also. We start from again the location x and go and we'll find the 11, we'll just erase, and at x plus 990 also we will just erase the location in the location of x plus 220 where 10 is stored, the bigger number location also stored, right? Just we will erase that x plus 990. So in this way the sets are working. So sets are generally built on the linked list only. Okay, and coming to unadd set, so what unadd set is doing is like, unadd set is again it is completely logical thing, because some simple unadd set is to before you have to know unadd set, you have to know this thing. Let's say you have the numbers of 1 to 100. Okay, you want to store somewhere, so what you will do is like, we wrote some function which is called f of x equal to x divided remainder modulo 10. So what it will do is like, whatever the numbers give the same value will store at same location, so the numbers 1, 11, 21, 91, these all will locate at some place, at some continuous place. Okay, and 2, 22, 32, 12, 42, 92, these will locate at some place. Let's say this is a vector, continuous space vector. Okay, and these locations also continuous location, 1, 2, 3, 4 and 0. So here 23, 13, these numbers will be there. Here whatever gives the same answer, these are the answers, let's say. So 24, 44 like this. Here 10, 0, 20 like this. So in this situation, if anyone want to know, this we stored in this pattern at some way. It is vector and it vector of vectors. Okay, everything is continuous location. Every continuous location has these spaces. Okay, if someone want to find the whether the number 35 is there or 33 is there or not, so to know that, we'll just go to this location. We know here 33 won't be there. We no need to check all these things. We'll just go to the here and check here. So directly we can go here, no need of checking all these unnecessary things. So it again depends on the logic, what the numbers are going to insert, at what buckets we have to do. So this is called unordered set, basically unordered, because that is no ordered, just depends on this hash function, because this whole algorithm is called hashing. So unordered set. Unordered set has us dot find. It has the member function find. We can find any number at big O of, like at fastest than the normal set and faster than the vector also. So us dot find some number much faster. Us dot insert a number, it is also much faster, because just get the hash value and go to that bucket and insert that number. It is also much faster. Us dot back, these things won't be there, because unordered set doesn't have any order. It is just following the hash function. So these are the two functions. We can have us dot arrays. So what it will do, it will just go to the corresponding bucket, whether the number is there or not, it will just check and it will erase that number. In this way we have discussed what abhi tak vector, array, vector, we discussed array, vector, linked list. Okay, on top of the linked list tag is there. On the top of this queue is there, and one more, just array is the vector is the advanced topic of array, right? In the same way double linked list is there. We haven't discussed, no need of that. Similar to what we discussed for DQ. Using this DQ is there. This is the containers we are using C++. In other languages also similar containers we have used, but with different syntax and names. And set is using these logics, set, but with some proper left and right ka pattern we are following, set. And unordered set is completely different. At different locations we are, like internally we can, here vector we can use, or here we can set we can use. So that whole thing is depend on the how internal implementations are done. It again different for the different programming language, not at almost different. At 95% all are similarly implemented. Small changes they may done for the faster efficiency. Okay, so unordered set. So 1, 2, 3, 4, 5, 6. These are the 6 basic data structures. With these things, yeah.